Chang'e are 6 lunar probe samples from the unexplored far side of the Moon. The Moon has always been a symbol of wonder, mystery, and human curiosity. For millennia, humans have gazed at it from Earth, seeing only one side. But what about the hidden far side, the so-called dark side that no one had ever explored up close? Chinese scientists make a new discovery about the dark side of the Moon that changes everything we know. China's daring lunar missions have shattered the silence, bringing back samples and data that hold secrets older than Earth itself. These revelations are rewriting lunar history, the eternal mystery of the dark side. For millennia, the Moon has captured the imagination of humanity. Poets, dreamers, scientists, all drawn to the silent glow that hangs above Earth each night. Yet half of this celestial companion has remained hidden from human eyes, the so-called dark side of the Moon. Not because it never sees sunlight, but because it always faces away from Earth. It is a world shrouded in secrecy, shielded from direct view, untouched and unexplored by Apollo astronauts. A realm of speculation more than knowledge. For decades, scientists wondered what lies on the far side. Is it barren, lifeless, identical to the near side we know so well? Or does it hold mysteries powerful enough to shake our understanding of planetary science, geology, and perhaps even the future of humanity itself? No one could have predicted that one day, China would be the nation to answer this question. And in doing so, they would uncover a discovery so profound that this changes everything. On December 1, 2020, history was set in motion. From the Wang Space Launch Center in Hainan Province, China launched its most ambitious lunar mission yet, Chang'e 5. The spacecraft was massive, nearly 8 tons. A robotic marvel designed for a mission unseen since the 1970s, land on the Moon, drill deep beneath its surface, retrieve ancient samples, and return them safely to Earth. The world watched as the rocket soared skyward, carrying with it not only advanced technology, but also China's aspirations to stand among the greatest spacefaring nations in history. While the United States had planted its flag on the lunar surface decades earlier, China was not aiming for symbolism. It was aiming for discovery. And soon it would deliver something far more valuable than a flag. Proof that the Moon is not what we thought it was. Touchdown in uncharted territory. The decision to land at Oannes Proalarum was not one made lightly. It was a bold deviation from previous missions, a venture into a terrain far more ancient and enigmatic than the familiar lunar plains explored during the Apollo era. Oceanus Proalarum, the ocean of storms, stretched vast and ominous, its volcanic plains marked by a geological complexity that hinted at stories buried deep within the Moon's crust. Rising prominently near the site was Mons Rimke, an isolated volcanic dome that stood as a silent sentinel over an area untouched by human or robotic hands. Unlike the smooth Maria chosen by NASA decades earlier, the Chinese National Space Administration selected a region that defied expectations. This was not a site chosen for its ease or safety, but for its potential to unravel the mysteries of the Moon's past. Scientists noted that unlike Apollo's sites, which were geologically younger and more accessible, this region promised something different, older, stranger, and potentially far more revealing. But the ambition of Chang'e 5 didn't stop with geology. The mission's location posed an additional challenge. The Moon's far side is beyond the reach of direct communication with Earth, and no signal could travel uninterrupted from that remote region. To solve this, China placed the relay satellite Kueo in a halo orbit around the Earth-Moon L2 range point, creating a vital bridge that allowed signals to flow between the spacecraft and mission control. This solution was an engineering marvel, demonstrating China's growing sophistication in deep space communication. When Chang'e 5 descended and touched down softly, it was more than a landing. It was a statement. The spacecraft's gentle descent marked a turning point not just for China, but for the world's perception of space exploration. The touchdown was executed with precise autonomy, guided not only by pre-programmed algorithms, but by a dynamic navigation system capable of avoiding last-minute hazards. The lander's legs extended, absorbing the shock as it settled into the dust of another world. At that moment, a new era quietly began for lunar exploration. What went unnoticed in the immediate coverage was the magnitude of what lay beneath. In the silence that followed the descent, there was no fanfare, no ticker tape parades. But buried under that ancient regolith, undisturbed for billions of years, was a scientific time capsule waiting to be opened. One that would reshape humanity's understanding of the moon's volcanic history and the solar system's early days. Few realized at the time that these hidden treasures had the potential to rewrite textbooks, digging deeper than ever before. The surface of the moon is deceptive. To the untrained eye, it is static. Grey dust and silent shadows. But just beneath that fragile skin lies an archive of cosmic memory. Chang'e 5's mission objective was to go deeper than any modern lander had dared. Unlike previous missions which had scraped only shallow layers of lunar dust, Chang'e 5 drilled beneath the surface into ancient undisturbed strata. The lander, equipped with a robotic arm and a sophisticated drill, began its operation immediately after touchdown, working against the clock, constrained by the harsh reality of a single lunar daylight cycle equivalent to just 14 Earth days. The mission team orchestrated a precisely timed extraction of regolith and rock. Within that short window, the instruments dug deep into the moon's history, retrieving samples that had remained untouched for billions of years. These samples were unlike any others returned to Earth. The surface material, while informative, could only offer recent history. But the deeper cores Chang'e 5 retrieved held secrets from a primordial era. These were not ordinary rocks. They were capsules of time, witnesses to the moon's volcanic activity, meteorite bombardments, and geological shifts stretching back further than any Apollo sample. Analysis of these cores would later reveal a complex history of lava flows and mineral compositions previously unseen, pointing to prolonged volcanic activity that persisted longer than scientists had believed possible. As the lunar sun began to dip toward the horizon and the lander systems neared the end of their thermal limit, the ascent stage prepared for its departure. With its cache of ancient lunar material sealed inside a return capsule, it fired its engines and lifted off in a graceful arc. With precious cargo in hand, the ascent module lifted off, rejoining the orbiter in a display of flawless precision. This moment, the first successful lunar sample return in over 4 decades, was not just a technological milestone, but a symbolic reclaiming of humanity's curiosity. For the first time in decades, humanity had pulled treasures from the moon's depths and sent them back to Earth. The significance of this act rippled quietly through the global scientific community. These samples were not mere rocks. They were messengers from a time before Earth's continents had formed, before life had emerged, before the solar system had settled into its current shape. With them, China had not only advanced the frontier of space engineering, but had reached back into time itself and brought a piece of it home. The return that shook the world. On December 17, 2020, a silvery capsule hurtled through the darkened skies above Earth, glowing like a miniature comet as it pierced the atmosphere at hypersonic speeds. It was a sight both humbling and extraordinary. The fiery descent of Chang'e 5's return module. A technological marvel built with precision and purpose. As it descended into the snowy plains of Inner Mongolia, its parachutes unfurled gracefully, guiding it to a gentle, calculated landing amid the vast stillness of the steppe. Inside that capsule lay something the world had not seen in nearly half a century: pristine lunar material. These were the first samples returned from the moon since the Soviet Union's Luna 24 mission in 1976. For scientists, engineers, and space enthusiasts alike, this was a moment steeped in history and charged with renewed hope. The silence of space had been broken by the whisper of possibility. Around the globe, teams of researchers gathered in labs, their eyes fixed on live streams, telemetry, and internal updates. In those small grains of regolith, cradled inside sterile containers, was the potential to reshape our understanding of the moon's past and, by extension, our own. No longer was this solely a triumph for China's National Space Agency. It was a bold statement to the world that exploration still thrived, that curiosity had not waned, and that the stars remained within reach. This was more than a national achievement for China. It was a milestone for all of humanity. This reality echoed through the halls of observatories, control centers, and academic institutions. The mission had not only demonstrated technical prowess, but also rekindled a sense of shared human wonder. The contents of the capsule were more than dust and rock. They were messengers, silent emissaries from a world just beyond Earth's reach. These were not surface ski or legacy relics. They were targeted extractions from an unexplored volcanic region in Oanes Proalarum, a place geologically distinct from where the Apollo missions had landed. This choice was intentional. It was strategic. It was meant to answer questions Apollo had not touched. And so, as scientists delicately unpacked the samples under sterile conditions with robotic arms and gloved chambers, they knew they were not merely handling soil. They were preparing to open a book whose pages had not been turned in billions of years. The anticipation was electric. The stage was set for revelations. Ancient secrets beneath the dust. The first tests hinted at something remarkable. As the samples were probed with electron microscopes and subjected to spectroscopic analysis, they seemed to suggest a story far older and more complex than previously imagined. These weren't just lunar rocks. They appeared in some ways like time capsules, crystallized remnants from an ancient epoch. Preliminary geochronological studies hinted that some of these materials could be significantly older than the lunar samples retrieved during the Apollo era. If confirmed, such a revelation might extend and deepen the Moon's evolutionary timeline in ways scientists are only beginning to speculate about. The implications alone sent ripples of excitement through the scientific community, opening new questions about the Moon's formation and geological history. Among the more intriguing possibilities were tiny, glinting spheres no larger than grains of salt, microscopic glass beads that may have formed during violent meteorite impacts. Early analysis suggested that under certain conditions, these beads could potentially trap molecular water within their vitrified walls, not in puddles, not in ice caps, but minute pockets of H2O suspended in silicate glass. If verified, it would challenge one of the most long-held assumptions about the Moon, that it is bone dry, a desert of rock and dust. For generations, this perceived barrenness shaped mission planning, spacecraft design, and public imagination. The Moon was beautiful, but barren, poetic, but parched. Now, even the suggestion of hidden water began to unravel that narrative. While each reservoir might be tiny, collectively they could hint at the Moon holding far more than previously imagined. The potential implications, though speculative, were staggering. Conversations quickly shifted from theoretical musings to practical possibilities. If such water could exist and be extracted, future astronauts might not need to transport all life-sustaining resources from Earth, a prospect that has long been considered both costly and logistically daunting. Instead, water might be mined in situ, potentially providing hydration, nourishing greenhouse crops, or even, if split into hydrogen and oxygen, fueling return trips or deeper space missions. The speculation alone sparked visions of survival and sustainability on the lunar surface. In these specks of dust and hypothetical droplets, a new vision of human presence began to emerge. A Moon that could support life, not for days, but potentially for weeks, months, or longer. The idea of a permanent lunar outpost, once a distant fantasy, seemed suddenly conceivable, grounded in the tantalizing possibilities of physical evidence. If water could indeed be harvested, astronauts might one day drink, grow crops, and generate rocket fuel on the Moon itself. Permanent bases and colonies could shift from mere imagination to practical planning. Each study, each peer-reviewed paper or mission update added layers of intrigue, suggesting not just what the Moon is, but what it might become. And as data streamed in from labs across the globe, one phrase began to echo louder than the rest: this changes everything. Quantifying the impossible. As scientists began to consider the potential scale of what Chang'e 5 might have uncovered, imagination raced alongside preliminary data. Calculations, though far from definitive, suggested tantalizing possibilities. If even a small fraction of lunar regolith contained water at levels hinted by early analyses, the Moon could harbor far more liquid than anyone had previously imagined. What was once dismissed as sterile gray dust might yield hundreds or even thousands of liters of water per ton under the right conditions. Such speculation upended decades of assumptions. For years, mission planners focused on the Moon's polar craters, regions of permanent shadow, as the only plausible repositories of ice. But if water exists more widely, mid-latitude and equatorial sites could suddenly become viable options for long-term habitation. The Moon, once considered a barren satellite, might instead be a resource-rich environment capable of supporting sustained human presence far beyond short-term missions. Water, even in small amounts, carries enormous implications. Extracted through future technologies, it could provide hydration for astronauts, nurture greenhouse crops, and through electrolysis, generate breathable air and rocket fuel. The Moon might evolve from a scientific outpost into a functional hub, a stepping stone for journeys to Mars, the asteroid belt, and beyond. Even the mere possibility of widespread lunar water forces a reimagining of exploration strategies, mission design, and long-term colonization plans. This vision transforms the Moon in human imagination. No longer a silent, inert rock orbiting Earth, it becomes a place of potential, a frontier where ambition and survival converge. The impossible begins to take shape as a plausible reality, and the Moon's once limited role in space exploration could expand dramatically. While much remains unproven, the notion that these specks of regolith might harbor usable water challenges us to rethink what is feasible, turning centuries of assumptions on their head and hinting at a future where the Moon is not just a destination, but a foundation for humanity's next steps in space. A mineral that could change humanity's future. Just as one breakthrough hinted at a radically different Moon, another emerged, one that could be even more consequential. Preliminary studies of the lunar soil returned by Chang'e 5 suggested the presence of a previously unknown substance. Researchers provisionally named it Changes Site Y, a phosphate mineral that appears to form under unique lunar conditions. At first, it seemed like a curious footnote in the Moon's geological story, but further analysis raised a provocative possibility. Its crystalline structure might be capable of hosting helium-3, a rare isotope nearly absent on Earth, but long theorized as a potential fuel for nuclear fusion. Fusion, the process that powers the Sun, has long been considered the holy grail of energy. Unlike fission, which splits atoms and produces radioactive waste, fusion combines atoms to release immense energy with theoretically minimal environmental impact. Even small amounts of helium-3 could in theory produce vast quantities of clean energy. On Earth, helium-3 is scarce, locked in the atmosphere or buried deep within the crust. The Moon, by contrast, has been bombarded for billions of years by the solar wind, which deposits helium-3 on its surface. If Changhai Y indeed concentrates and stores this isotope, it could turn the Moon into a potential reservoir of energy unlike anything humanity has ever known. While these ideas remain speculative, the implications are staggering. A lunar supply of helium-3 could one day power cities for decades, potentially transforming energy economics, mitigating climate change, and reducing reliance on fossil fuels. A new form of space race might emerge, not for prestige, but for access to this extraordinary resource where the stakes are survival and sustainability. The Moon, long thought to be a silent barren satellite, could in this scenario become a linchpin in humanity's energy future, a stepping stone to the stars, and a potential key to securing life on Earth. Even as scientists continue to investigate, the tantalizing possibility of lunar helium-3 has reshaped how we imagine the Moon's role in our civilization. The revelation no one saw coming. As the scientific community reeled from recent discoveries surrounding lunar geology, another revelation erupted from the cosmic silence, thrusting the world into a new era of celestial understanding. China's Chang'e 6 mission, tasked with collecting samples from the far side of the Moon, unearthed findings that jolted the foundations of planetary science itself. In a groundbreaking paper published in Nature Communications, researchers disclosed that the lunar mantle lying beneath the Moon's far side bore a chemical signature unlike anything seen before. This mantle was found to be significantly more reduced, indicating it existed in a lower oxidation state compared to its counterpart on the near side. In scientific terms, it was either far more primitive, a direct window into the Moon's earliest history, or had been dramatically altered by cataclysmic collisions during the turbulent dawn of the solar system. This wasn't a trivial compositional discrepancy. It wasn't surface dust or topsoil variation. It was deep, hundreds of kilometers deep. And that depth brought with it a truth that had been invisible, even unimaginable for decades. The Moon, long thought to be a homogeneous body with only superficial differences across its two hemispheres, was revealed to be fundamentally bifurcated in its geological identity. The two sides of our celestial neighbor are not twins. They are strangers. This revelation rippled through the scientific world like a seismic wave through lunar rock. It dismantled long-accepted models of how the Moon formed, particularly those suggesting a uniformly mixed post-collision body from the hypothesized giant impact that birthed it. Suddenly everything was on the table again. Multiple impacts, asymmetric cooling, hidden magnetic fields, ancient volcanic activity long extinct, all potential threads in this newly unraveling lunar tapestry. The story exploded beyond scientific journals. Mainstream voices Tucker Carlson, Laura Ingraham, Jesse Waters took to the airwaves. Not to dispute, but to underscore. This wasn't routine space chatter or sterile academic debate. This was a seismic event, a pivot point in the timeline of space exploration. For the first time, humanity could declare without speculation or theory, the far side of the moon is not what we thought it was. And with that, a new narrative was born. One that renders previous assumptions obsolete. One that changes everything. A future forever changed. The ramifications of these lunar discoveries could be as vast as space itself. Water once thought scarce might be more widespread than previously imagined, potentially scattered across the moon's surface, frozen in craters or embedded in regolith waiting to be unlocked. Even small reserves could transform the prospects for human presence. Lunar habitats, fuel production, and agricultural support systems could all hinge on this resource, making permanent outposts not just conceivable, but potentially feasible.